Today's daily LeetCode problem of the day is find the minimum and maximum number of nodes between critical points. Number 2058. For this problem, we want to find a critical point in a linked list, which is either the local maxima or the local minima. For maxima, it has to be strictly greater than the previous and the next node, and minima has to be strictly smaller than the previous and the next node. There can only be a maxima and minima if there exists both a previous and a next node. After traversing the list, we want to return an array of length 2 containing the minimum distance and the maximum distance, or these are the minimum distance between any two distinct critical points, and maximum distance is the maximum distance between any two critical points. If there's fewer than two critical points, we can return -1, -1. So for this problem, to solve this, we want to identify 7 key components to traverse and keep track of this list. So the first thing is our integer result, which is going to be what our output is, so -1, -1 to initialize it. We are also going to have an integer minimum distance, which is going to be the minimum distance between any two critical points, and that's going to start as integer dot max value. Therefore, there's always going to be a smaller value between two critical points. And then we're going to have a list node current, which is going to be the current node that we are looking at, and it's going to be equal to head.next. That way we always have a previous node behind our current node, and we're going to stop before we reach the end of the list, so we're always going to have a node in front of it as well. We're also going to identify a list node prev, which is going to be equal to our head node, and it's always going to be right behind our current node. We're also going to identify an integer current position, which is going to be the current node position that we're looking at. So that could start as 1. And we're going to have an int prev crit, which is going to be the most previous critical point we have identified. We are going to use that to identify our minimum distance. That could be equal to 0. And we're going to have an int first crit, which we're going to use to identify our maximum distance between two critical points. That will also be equal to 0. After that, we can start a while loop, and this loop is going to transverse our entire linked list. So as long as current.next is not equal to null, we will be able to iterate through this while loop. So in this while loop, we're going to check, the first condition we're going to check is if our current node is a maxima or minima. So to do that, we'll do an if statement. So if current.value is greater than current.next.value and current.value is greater than previous.value, or if current.value is less than current.next.value and current.value is less than previous.value. So we initially check if it is a maxima, and then we check if it is a minimum. So if we pass that if statement, there are two things we want to check. First thing is if the first crit point has been identified. If it has not been identified, we do not have another critical point to compare this critical point to. So this is going to be our first critical point. So if first crit is equal to 0, we're going to set our first crit to our current position and our previous crit to our current position. So now we have our previous crit to determine our minimum distance and our first crit to determine our maximum distance. Otherwise, when we identify this critical point and we have identified our first crit point and our previous crit point, we can now determine our minimum distance. So min dist is going to be equal to math.min. We're going to pass it min dist, and we're going to pass it current position minus our previous critical point. So this will determine whether if min dist is still the smallest value between two critical points, or if our current position minus our previous critical point is smaller. Either way, we're going to want to make our previous critical point equal to our current position. So in fact, we can even remove it from right here because no matter what, it will hit that value. So after traversing our while loop, we simply need to increment our current and our previous value. So prev will be equal to current will be equal to current dot next, and our current position will just be incremented by 1. Now after we break our while loop, we just need to do a simple check to see if min dist is still equal to integer dot max value. If it's not, then we can set our result of 0 to our minimum dist, and result of 1 can be equal to our current position minus our first position, our first grid. Either way, we're going to return our result. So we should actually do our previous critical point here minus our first critical point. This should pass our test cases, and this should pass all solutions. Okay, now for Python. I think I broke LeetCode.